Hi guys, and welcome to the term 3 work through of the maths content for grade 7, 8 and 9. So we're going to start off with algebraic expressions, which grade 7 and 8 learn. So let's look at some theory first. So the first thing is, what are variables? So variables are letters that can represent different numbers, okay, or values. So they can change. They don't always stay the same. So while you can always have an x, the value of x can always be different. Whereas a constant is a number that stays the same. It never changes. So constants, and I'll demonstrate this in a little bit, don't change. And then of course you need to know like and unlike terms. So like terms have the same variables which have the same exponents. If you have two sets of variables but their exponents are different, then they are actually unlike terms. So remember also that terms are separated by pluses and minuses, and this is something that a lot of students struggle with. Terms are not separated by timesing and dividing. They are only separated by pluses and minuses. So let's go through how we can teach the difference between variables and constants. So we're going to go into our calculator and we're going to go look at table mode. So I'm going to go to mode and I'm going to press 2 for table. Okay. Then in function 1, what I'm going to do is I'm going to put in any value, any constant. So for example, I'm just going to put in a 5. And then if I press equals until I reach the table, we can see that 5 doesn't change. It always stays the same. No matter what we do on this end, 5 will always be 5 because nothing affects that 5. Okay. But what we can do is, so let's leave 5 in function 1. And in function 2, we're just going to stick an x inside. So we're going to say RCL, RCL. Okay, to make an x, we're going to press equals, equals, equals. And now we can see that while 5 stays the same, our x is always changing. And it changes based on what value we put into it. So that is a variable and 5 is a constant number. So from there, we also need to be able to simplify algebraic expressions. So in grade 8, we need to be able to multiply and divide monomials, binomials, and trinomials with integers and monomials. And then, of course, add and subtract our glorious like terms, find squares, cubes, and roots of algebraic terms, and use substitution. So here are 2 worksheets for grade 8 that you can download from Maths at Sharp. And then, of course, some really common issues that learners struggle with. Obviously, they struggle to identify like and unlike terms. So particularly when we're talking through an x and an x squared, they are completely different. They are not the same because x squared is actually x times x. So we need to explain this to them in a really straightforward way. And then, of course, they also struggle with exponents and roots, and they struggle with the definition of a term. In other words, how are terms separated by pluses and minuses. And then, of course, they struggle with substitution because they don't understand how terms work with each other. So it's very important that they get the basics of algebra correct. So I wanted to demonstrate to you like and unlike terms. So we're going to go back to table mode. And I'm going to clear function 1. And what I'm going to do is I'm going to make just an x here. Okay. Then in function 2, let's not confuse ourselves. In function 2, what we're going to do is press an x, but we're going to square it. Okay, so in function 1, we've got x. In function 2, we've got x squared. And then if we press equals, 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 we can see that these are not the same if we look at the 2 values in our answer columns because they change. So therefore, these are not like terms because when we substitute in, they become different values. So of course, we can also do substitution, and it's really quite nice and easy to do on the calculator as well. So I'm just going to go home and I'm going to save values. So I'm going to store different values into my A and B. So in my example, I've got A is equal to 1 and B is equal to -3. So A is equal to 1. So I'm going to say 1 and store it in A. And for B, we use the negative sign, not the minus sign, otherwise it will create an error, and we store it in B. Now, if we wanted to write an expression, so for example, ab squared plus a squared b, and find what the value is when you substitute in it, all we do is we use our alpha keys. We're going to say alpha a, then alpha b, and that's squared, plus alpha a, and now that's squared, and then alpha b. And all we have to do is press equals, and we get that answer. Of course, we can also change the value in A and B. So we can say, let's make A 2 and let's make B 5. Okay, and then if I go back up to my expression and I press equals, it will, of course, change that value as well. So from algebraic expressions, we then move into algebraic equations, which again are only done in grade 7 and 8 and 23, according to the 8 key documents. So for grade 7, we've got number sentences, and then we need to know how to deal with problem situations, variables and constants, which we just spoke about now. And then, of course, solving by inspection, trial and error, and substitution. And then, of course, in grade 8, we need to be able to do substitution to create ordered pairs. In other words, we can create a table and find out what works. So again, here are links to worksheets. So these ones are from worksheetworks.com. We have a lot of great examples, especially for working through the language of algebra and being able to write a problem story into an algebraic expression, which is actually a really critical skill. Because in maths, one of the core things that we actually want to be teaching our students is how to take a problem in real life and solve it mathematically. So this is a fantastic skill to practice. So then, of course, some common issues, understanding mathematical language, which is why we need to practice those things. So some suggestions would be to use a maths dictionary. There are some fantastic options out there. If you do have a question or you'd like a recommendation, I can give you some suggestions. And then, of course, you can always create your own with your students. So get them to get a tiny A5 little book. And then every time you do a lesson, either at the beginning or at the end, you can add vocabulary to your dictionary. And this is particularly important for students whose first language is not what you are teaching in. So if you're an English teacher, but you've got students who are Zulu and Sesotho, they first have to translate from English into Sesotho or Zulu in order to understand what is going on. So it's very important that you create these dictionaries that have very basic language so that the students can refer back to them, especially when they get stuck. Okay, and then of course you can always do vocabulary tests at the end of the week. Kahoot is a great choice for this, and it really makes it fun and interactive as well. And then remind your students what variables and constants are, and of course, solving by trial and error. Now, solving by yes. So let's start with solving by inspection. So of course, solving by inspection means we look at the expression that we're given and we try and figure out the missing piece. Okay, so what is equal to 5 times 10? Well, 5 times 10 is 50, so we can fill that in. Or we can say 50 is equal to what times 10? Well, obviously 5, because we've seen the example. Or 50 is equal to 5 times what? So it's just different ways of being able to solve a straightforward equation with a missing piece. Okay. So you really need to know your mental maths well in order to be able to solve by inspection quickly. Now, the other thing is that you need to be able to solve by trial and error. And I feel like this is such a critical skill that we need to pass on to our students, because when we teach them how to solve by trial and error, we're not just teaching them to solve by trial and error in maths, we're teaching them a skill that they're going to use for a long time outside of school that they're not aware is a math skill. Okay, so Wiki calls it a fundamental method of problem solving. And of course, repetition is key, because obviously you have to try a couple of times in order to get it right. You don't always get it right the first time. That's the whole point of trial and error. And the whole struggle around it is actually important. And it actually helps students to learn by struggling with a particular topic. So think about programming and a light bulb. I mean, how many times did Edison try to figure out the right light bulb before he got it right? It took him a long time. So you obviously, pushing through and having perseverance is something that we need to teach our students as well. So examples with trial and error. So what we could do is we could say, okay, what divided by 7 plus 2 gives me 10. So I'm going to guess that I've got to have a multiple of 7. So I'm going to guess 28. So 28 divided by 7 is 4, plus 2 gives me 6, which is not 10. So that's not correct. So I'm going to try 42. 42 is a multiple of 7. So 42 divided by 7 is 6, plus 2 gives me 8. So that's still not what I'm looking for. So I'm going to go up to 49. 49 divided by 7 is 7, plus 2 is 9. Still not what I'm looking for. So I'm going to try 56. So 56 divided by 7 is 8, plus 2 gives me 10. So now I have found my solution, which we know we can fill in the blank, which is now 56. Okay. Then again, you can do the same thing here. So let me just do it. So we've got what times 4 minus 5 will give me 11. So again, let's just start with 5. You choose a random number that you sort of think is going to work. So 5 times 4 is 20. Minus 5 gives us 15. So that's too high. So let's go down a notch. 4 times 4 is 16. Minus 5 is 11. So we have found it on the second go round. Lucky us. Okay, so you can see it takes a little bit of practice. And obviously, the more practice that you do, the better you get at it. Okay, so the other thing that you need to be able to do is to create ordered pairs. And this is a fantastic introduction to graphs. Maths is so interwoven with all the different topics. So it's really great to be able to introduce graphs here, introduce the basics of graphs to your students using this method. So what they want is to create ordered pairs. So again, we're going to use our magical table mode, and we're going to say, actually, let me go back to my screen so you can see. So we have an example where we say, what is equal to 5 times something plus 2? So we're going to substitute that something with an x into our table mode. So we're going to have what is equal to 5 times x plus 2. Okay, and then we just go through, and now we've got, if x is 0, our answer will be 2. If x is 1, our answer will be 7. If x is 2, our answer will be 12. And of course, we can do the integer side of things as well. And because your table is unlimited in either direction, it doesn't actually matter where you start your table from. So the next topic is construction of geometric figures. So constructions in grade 8 and 9, they are actually just asking you to actually give them to the students and then to ask questions based on the constructions that you've been given. But in grade 7, you still actually need to do the constructions with your students. In other words, with your protractor and your, I've lost that word, with your protractor and your compass. So you need to be able to construct various angles. You need to be able to construct circles, parallel lines, and perpendicular lines. And of course, you need to be able to name the parts of the circle. And this is such an important thing for them to learn, because even in grade 12 technical maths, you still need to be able to name the same parts of these circles. So very important. So students often need to have the tools for like the protractor and the compass, but they don't have them. Just funds, or they've forgotten them or something. So we need to make sure when we are doing constructions that we actually have a compass and a protractor. So you can do makeshift things. So some suggestions is a compass, use a length of string tied to 2 pencils. So just hold one pencil on one side and then draw using the other pencil. For a protractor, you can print a protractor onto a clear plastic sheet, like those projector sheets. They do go through most printers. So I've actually linked to a printer-friendly protractor that you can use. So what you can do is print a couple of these onto one sheet, cut them out, and this is a very cheap way to have a project available for students who don't have their own. And in fact, you can get them to cut their own out if that's something that you wanted to do with them as part of the task. Okay, then Maths is Fun is really great. It's got a lovely, lovely constructions function. So I'm just going to share this with you. Okay, so what it will do is allow you to actually create different constructions. So you can just choose what construction you want to do. So perpendicular line, parallel line through points. So it's got a little bit of adverts, but what it will do is actually help you. And so you can actually play the video and then it will show you what to do, which is really nice. So your students can actually watch the video and then try it themselves to create a, this one is parallel lines. So it's a really lovely, I mean, how fantastic is this? And it's all free resources. So Maths is Fun is fantastic. It's really nice tool to use. And then of course you can use GeoGebra. It's also wonderful. It doesn't have an obvious protractor and compass. But it does help you create constructions as well if you do have a computer science access. Khan Academy has wonderful videos. So if that's not something that you wanted to do and you just wanted to show them a video, they've got fantastic construction videos. And then of course an interactive construction maths pad. So if your kids have access to either a pad or a tablet, or you have a math center, you've actually got a protractor, so you can just pull out the length and then lock it, and then you just there we go, draw your circle there. And then of course you've also got a protractor, so you can measure your angles. You've got a ruler. Okay, so if you're done with the ruler, you can just switch it off. Okay, and then of course different colors, different line sizes, etc., etc. So really such a lovely tool to be able to share with your students as well. So from there, we move on to the lovely topic of geometry of straight lines. So this is actually a poster that we created quite a while ago. So it is linked in the presentation for you. So if you click on that picture, it will take you to this poster that you can then print and put into your class for your students. So of course, remember your theory, so your line segment. A segment has 2 endpoints, array has 1 endpoint and has an arrow, so it gives direction. A straight line is a set of all points. It has no curves, it always is 180 degrees. Parallel lines are 2 lines that are always equally distant from each other, so they will never ever meet or touch. And perpendicular lines are 2 lines that are at right angles to each other. So what I liked, I always had trouble remembering things, so I used to make up my own rhymes. So we always know fun, and then I said with the CIA. Okay, so you can see fun is corresponding angles, co-interior angles, and of course alternating angles there as well. So tips and tricks. So some tips and tricks. Obviously, here is a link to the worksheets for geometry. And then, of course, you can use GeoGebra. So this is just an example of what you can do in GeoGebra with parallel lines and, of course, inserting angles, creating perpendicular lines. It's a really fantastic tool. And then, of course, Maths is Fun also has some great videos to show geometry. Use a string for creating parallel and perpendicular lines. And then of course a project or a game, you could create a maze using different types of angles or lines, or create a dance with the same sort of theme. And then of course, remember, this is a very visual topic, so your visual learners are going to do fantastically well in this. Then geometry of 2D shapes, again, for all 3 grades. So in grade 7, you need to be able to classify triangles and quadrilaterals. And of course, you need to be able to do similarity and congruency. Then in grade 8, you have proof through construction. So you need to give them the constructions, and then they need to be able to find the sum of angles in a triangle, in an isosceles triangle, and in an equilateral triangle as well. Then for grade 9, it's the exterior angle of a triangle, and you need to be able to investigate the sides, angles, and diagonals of quadrilaterals. Then, of course, here are some worksheets for you as well. And this, again, is another poster that we created that you can download and print off for your class. So some ideas: you can play shape snap with similarity and congruency. And then, of course, look for shapes around us, or play with tangrams. We used to do this when I was in school, and it's such a great exercise for allowing students to manipulate shapes and see how they fit together. Or if you're feeling particularly enthusiastic, ask them to write a story about the journey of a quadrilateral that turns into something else. So from a trapezium to a rectangle, or a kite to a rhombus, or something along those lines. You know, something that shows that they understand the changes between the two different shapes. So then we have the topic of transformation geometry, which is covered in grade 7 and 9. So we need to have graph paper. So if you need graph paper, this one is great. It's also free to download. And then you need to be able to explain the different translations. So translations as in shifting a point up and down, or left and right. Reflections, where you have a mirror image. Rotations, where we twist a shape or point around another point, and lines of symmetry, where we create a mirror image around this line of symmetry. Then, of course, an enlargement is making a shape bigger, and of course, a reduction is making it smaller. So some suggestions: Maths is Fun, again, has some lovely transformation tools. So this link here is directly linked to the transformation tools. GeoGebra, again, is also really great. Then, of course, Interactive Maths has some lovely GeoGebra applets that you can use online. So that's also nice. MathsPad, which is this picture over here, also has lovely options for transformations. And then, of course, this is a link to all of the worksheets. Then grade 8 and 9. Oh, sorry, just for grade 9, we cover functions and relationships in term 3. And this article here is actually from my personal blog called mathsjourney.com, where you can go through various different ways of representing functions and relationships, and the journey it makes from a relationship into a graph, and how we view that. Then you have input values, which are the values that will change the result of your answer. So they are independent. It's what you're sticking into the machine. It's your ingredients for your cake. Your output values would be a vanilla cake, or a chocolate cake, or a brownie, or a donut, depending on the ingredients that you put in. Okay, so these are your final answers. So, of course, the flow diagrams here are diagrams that show us what happens. So we can give them a diagram which has the input and output values, and we can ask them what the relationship is. Or we can have an input value and a relationship and ask them for the output value, or vice versa. Have output values and a relationship and ask for the input values. Then, of course, you also have tables, and I'm not talking about the table where you sit at. I'm talking about, I'm sorry, that's terrible. And then equations are the relationships that with the variables that show what happens to the input value in order to get the output value. Now, a formula is an equation that is specific to a situation. Okay, so for example, the area of a shape. So each area will have a different, or each shape will have a different formula for area. Then, of course, here are worksheets from Maths Sharp with various functions and relationships. So you can, again, create a table from an equation. So we can say our equation is y is equal to 3x plus 2. So we're going to go back to our table mode. And we're already in there. So all I'm going to do is type in 3 RCL plus 2 to make my equation, because remember, this is always equal to y, and then equals. And we've got our table with our various values. So our x substituted and our y answer. Okay, so from there, we can move on to graphs. So graphs are an extension of functions and relationships, and we need to be able to interpret graphs. Are they increasing, as in going upwards? Are they decreasing, coming down? Are they staying the same, constant? And what does this tell us about the gradient? Well, if it's increasing, it's positive. If it's decreasing, it's negative. If it stays the same, the gradient is 0. Okay, and then of course you need to be able to draw straight line graphs using your tables and from a given equation. So we can use that equation in our table mode like we just did with functions and relationships in order to plot the coordinates of a graph. But we can also teach graphs. So I want to show you how to do that now as well. So back in table mode, what we're going to do is we're just going to type in an x. Okay, so in other words, y is equal to x, and we're going to plot these coordinates. So 5 and 5, x is 5, y is 5 onto a graph. Then what we're going to do is let's explore gradient first. So we're going to leave x here as it is. And in function 2, we're going to multiply the x by 2. And we're going to look at what happens. And we can see that y is now double. So when I draw my graph, my original graph, so I've got here, so my original graph looks like that. And my second answer 2 graph, it looks like that, where y is equal to 2x. Okay, so we can also then, let's leave that one there. We can also see what happens if we make it negative, right? And draw that graph. Now we can see that the points are now negative. So if I draw that graph, it's going to look like this. So it's a mirror image of this graph around the y-axis. And then, of course, we can also change our gradient. So we could also say, what if it was a, let's make it a half. Oopsie. Like so, equals, equals, equals. And now we can see the values are half of the size of the original value. So then it's going to look, let me draw this in a different color. It's going to look like that. Okay, so you can see the way it's been twisted, and depending on the gradient, how we change the gradient will depend on the slope of our line. Okay, so that value in front of x is our gradient, and we can also investigate then our y-intercept. So what we can do is leave this as x, and in our second one, I'll just clear it away, and then I'll say x plus 1 and equals, and equals, and equals. So now when we draw the graph, we've got this one, which we saw was just a standard line. And now we can see that every time we go up and down, you can just see it's one more, no matter where we are. It's always one more on the table. So when we draw the graph, it's just going to be a line that is parallel and is just shifted up 1 on the graph. Okay, and then of course, we can see that this y-intercept would obviously be 1. Now, if we changed it and instead we said x minus 1 and equals, 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 then we can see it's shifted down 1 every time. So when we draw in the graph, let me draw it in purple for fun, you can see that it's shifted down 1, and our y-intercept will be negative 1. So it's a really nice way to teach graphs to your students as well. So here are all the steps for you, and of course the various drawings that we did as well, and then the shifting the graph up and down, and much prettier looking graphs than the ones that I drew now. Awesome, guys. Thank you so much for your time today. I hope that you found this workshop both quick and helpful. And if you do need the notes, let me know. I'm happy to send them through to you. Have a super day further, and take a look at our other videos available on YouTube.